So here's a problem. What is the pH of a solution that contains 0.15 molar acetic acid and 0.1 molar sodium acetate? Well, if we look, we can notice that this is an acid, acetic acid, and if you remember the formula for acetic acid, HC2H3O2, you'll recognize that this is sodium acetate, and this right here is the conjugate base to acetic acid. So we now have this common ion in solution. This ion is part of acetic acid and it's part of sodium acetate, and it will now also affect the pH of the solution. So assumption number 1 suggests autoprotolysis is not significant, so the only amount of hydronium ion being produced will come from this reaction here and not from autoprotolysis. Then, knowing that we don't have any hydronium, if we were to calculate a Q value for this reaction, it would be 0, and a Q value of 0 is always smaller than a K value, even if K values are small. So this reaction has to proceed to the right. As it proceeds to the right, we'll get a change in the acetic acid concentration as it decreases, and an increase in the acetate concentration. But because of assumption number 2, we'll assume that this X is less than 1% of 5% of 0.150, and that this X is less than 5% of 0.1, and we will eliminate them from our calculation. This greatly simplifies the calculation, and as I mentioned, for common ion effect calculations, all of these assumptions are going to be valid, 1, 2, and 3. I will validate the assumptions 2 and 3 here in just a second. You will never have to do that. Just know that they will always be valid. So to solve for pH, we simply need the hydronium concentration. We're given Ka, we're given the concentrations of the weak acid and its conjugate base. We simply plug them in and rearrange to solve for the hydronium concentration. We then take the negative log of that to get pH. So to validate our assumption, was X really less than 5% of 0.15? Yes, it was. Was X really less than 5% of 0.1? Yes. And it turns out that for all problems in this class, that will be true. This is also a practical issue. When these assumptions are not valid, assumptions number 2 and assumption number 3, we really have a solution that doesn't have any practical purpose because it really is too dilute. Well, when I say practical purpose, we're going to talk about buffer solutions here in a minute, and essentially what we have here is a buffer solution, and it would not have any practical purpose if these concentrations were too dilute, and if they were too dilute, then we could not make these assumptions. So it just makes sense to make these 2 assumptions, or more appropriately, these 3 assumptions. The first one we always make, and then assumptions 2 and 3.